Alright, now today we'll be taking a look at the cosine function on the graph and just taking a look at what it does. Okay, so right now I do have the sine graph. I'm going to graph the cosine as one as well. And I'm going to graph at the same time, and I want you to take a look at it. Go ahead and pause the video and notice some differences between the two graphs. Hint, there's not much. They do achieve both the same type of heights. They both achieve the same type of lows. The only difference is that the cosine graph is about, if you notice the difference between where the actual similar places are, it's about pi halves units to the left. It's almost like I shifted the whole graph over. So here's the really cool thing, is that if you really did want to make them both the same, you would just take cosine and you would add pi halves. Oops, nope, you would have to add that inside. Who am I kidding? You have to put it inside. Okay, so let's just go ahead and make this plus pi halves. Oh, not plus. Let's do minus. There we go. And then you would actually make it all set up like this. And as you can see, the second I get rid of that, I'm actually going to go back to the original. Okay, so this is just y equals cosine of theta, or cosine of x in this case. Okay, now, just taking a look at it, the amplitude works the same. If you increase the number, it makes it bigger. If you make it negative, it flips it around. Okay, so that one's pretty simple. So let's go back to 1. Okay, and once again, B. If we increase B, we increase the wavelengths or cycles, whatever you want to call it, that are smashed into a normal period, which would be between 0 and 2 pi. Okay, so in other words, if we go up to 5, there will be 5 wavelengths between these two. Now, instead of on the sine where you count the middle of the actual wave as your beginning and ending points, you would count the tops. Okay, and with cosine, it's totally up to you how you want to do it. All right. Here's a really cool function I just learned about. Watch this. If we press the play button right next to the variable, it will actually increase it for you all the way up to 10, and then it will go down to about 0. Just drags it out, and then it goes back the other direction. Okay. All right, so some really cool stuff that you can actually do with this. All right, so back to the actual function. If we add the variable a and the variable b, the absolute value will be amplitude, just like with sine. The period will also be 2 pi divided by b, and there will be b wavelengths in one period from 0 to 2 pi. Now I've also realized that sometimes they might call it a cycle. Physicists call them wavelengths. You know, they're both the same thing. They both work the same way. Okay, but there's just that many in there. Okay, all right, now this one right here, once again, is the wavelength well, no, it's not the wavelength. Length of period for one wavelength. Okay, so as you work with this stuff, cosine, it's just going to be, it's just like the sine function, except it's shifted over to the left about pi halves units. Oops. There we go. Okay, it's just like sine. It's amazing how much they're very similar. Okay. All right, that's it for working with the cosine function as you're working with this stuff. I'll talk to you later. Bye.